Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Problem 133. For the series of new wrought iron pipes of absolute roughness 0.046 mm, shown below, changes in cross-sections are sudden. Entrance and exit flush and submerged. Entrance and exit are flush and submerged as shown. Determine the value of the head H, the difference in elevation between water surfaces in the two reservoirs. If part A, all losses are considered, and part B, only frictional losses are considered. The following data apply. The discharge Q is 60 liters per second of water at 15 degrees Celsius, where the viscosity is 0.00116 pascal second. L1 is 400 meters, diameter 1350 mm, F1 0.018, length of pipe 2 200 meters, diameter of pipe 2 200 millimeters, friction factor 2.017, length of pipe 3 300 meters, diameter pipe 3 300 mm, friction factor 3.018. Use the empirical formula. Loss coefficient for sudden contraction is 0.42 of quantity 1 minus small diameter square over bigger diameter square. In computing for loss coefficient for sudden contraction only at the junction between pipes whenever applicable. So the total head loss is equal to this difference in elevation big H, and that is equal to HF plus HM, where HF is the frictional sum of frictional losses due to pipe friction, and H sub M is the sum of the minor losses. So HF by Darcy-Weisbach formula is F1 L1 over diameter 1 times velocity head in pipe 1 plus F2 length of pipe 2 over diameter of pipe 2 times velocity head of pipe 2 plus F3 length of pipe 3 over diameter of pipe 3 times velocity head of pipe 3. So we can compute the velocity of each pipe, mean velocity of flow in each pipe, because the discharge is given. So V sub 1 is 4 times 0.06 divided by pi diameter of pipe 1 square. So pi 0.35 square, so 0.6236 meters per second. We then compute right away velocity head of pipe 1, which is 0.6236 square divided by 19.62, and that is equal to 0.01982 meter. V sub 2 is 4 times 0.06 divided by pi times 0.2 square, and that is equal to 1.910 meters per second. So the velocity head 1.91 square over 19.62 is equal to 0.1859 meter. Mean velocity of flow in pipe 3 is 4 times discharge 0.06 divided by pi times 0.3 square, and that is equal to 0.8488 meters per second. Then the velocity head 0.8488 square divided by 19.62, and that is equal to 0.03672 meters. We can then compute HF, which is equal to 0.018 times length 400 over diameter 0.35, velocity head 0.01982, plus friction head loss in pipe 2, friction factor 0.02, length 200 divided by diameter 0.2 times velocity head in pipe 2.1859, plus friction factor in pipe 3.018, length 300 meters divided by diameter 0.3 times velocity head in pipe 3.03672. So H sub F can now be computed, and it is equal to 4.229 meters. Then For the minor losses, we have at pipe entrance, zero point 0.5 of velocity head of pipe 1. So KSC is 0.42 quantity 1 minus 200 square over 350 square. The small diameter here in pipe 2 is 200 mm. The bigger diameter, which is in pipe 1, is 350, and we have sudden contraction here, expansion in the next joint, so it is 99 over 350. So 8 sub m is equal to 0.5 of velocity head of pipe 1, which is 0.01982, plus coefficient of sudden contraction 99 over 350 times velocity head of pipe 2, 0.1859. Then plus we have sudden expansion, which is V2 minus V3 quantity square. So it is quantity 1.91 minus 0.8488 quantity square over 2G. Then we have sudden enlargement here, which is the same formula as this, but vis-a-vis is 0, so therefore it reduces to velocity head in pipe 3. So plus 1 times 0.03672, or simply plus 0.03672. So 8 sub m therefore is equal to 0.1566 meters. So the value of h, which is hf plus hm, is equal to 4.229 plus 0.1566. So the difference in elevation is equal to 4.386 meters. Then in part B, only frictional losses are considered. This is the value of HF, and we ignore HM, so this is 0, so H is just HF. Therefore, the answer to part B is big H is equal to 4.229 meters. So that's it for this problem.